Hello, and this time I'm talking about parametric equations and how to find points where the parametric equations might intersect something else, or it might be intersecting the axes or another curve or straight line or something like that, and a couple of examples of how to do this. So maybe I won't answer everything that you need to know about this, but hopefully in seeing how I approach these two examples you can apply the same ideas to what you're needing to do. Okay, so find the points of intersection of the parabola x equals t squared and y equals 2t with this circle. Okay, so we've got a circle and the parabola's coming through. It might do this, or it might do that, or I suppose it might even do something like that. I mean, honestly don't know, but the point is it goes through it at some point, and we want to find the x and y coordinates for, I mean, here it could go through 4 times, really, couldn't it? So however many times it goes through, we want to know the x and y coordinates for these. Now, if you remember what parametric equations are, they are where you have this third variable, in this case t, and each point on this curve has a different value of t. And for this value of t, you can use this formula and this formula to work out the corresponding y and x coordinates that where you would plot that value of t. And that means that if we can find out the value of t for this point and this point, or all these points, wherever the intersections are, we can find the values of t for them, then we can just substitute them in and find out the values of x and y. So let's get rid of my drawings and let's see what we can do. As we have an equation here in terms of x and y, and we know what those x and y's are in t's, we can just substitute in and see what we get. So x squared. So that is t squared, but it's squared, so it is t to the power of 4 plus y squared, and that's this squared, so that's going to be 4t squared, minus 9 times x, so that's minus 9t squared, plus 4 equals 0. Now we can simplify the 4t squared and this, and I'm actually going to write this as t squared squared. Not plus, it's minus 5t squared plus 4 equals 0. I'm going to write it as t squared squared because, look, it looks like a quadratic but with t squared in it. So I'm going to rewrite this as u squared minus 5u plus 4 equals 0. And see if we can factorize this. In fact, no. Can we? Oh, yes, of course we can. 1 and 4. It's being silly now. Okay, so yes, we can. Of course we can. U times u is u squared. 1 times 4 is 4. And if they're both minus, then we're going to get the value of 5. So we get u equals 1 and u equals 4. But of course, u is actually t squared. So if t squared is 1 and 4, then t is going to be 1 or minus 1 and 4 or minus 4. So now we have these values of t. We've got 4 values of t, so it looks like we're going to get the example where it goes, oops, that's terrible, where it goes through 4 times, and we can find out what they are. So let's put each of them in. If we put in positive 1, we're going to get the coordinate, oh, that's the next video. If we put in positive 1, then we're going to get the coordinate 1 squared is 1, and 2 times 1 is 2. If we put in negative 1, we're still going to get 1, and we're going to get minus 2, because minus 1 times that. If we put in positive 4, we're going to get 16, and 2 times 4 is 8, and we're going to get... No, what am I talking about? I didn't square root this, did I? You've all been screaming at the video for ages. This was t squared, and I just deleted it, and I actually forgot to square root it. Goodness me. I think because when it was 1, I didn't have to do anything, but when it was a 4, so I didn't do anything there either, so apologies. So 2. Just thinking that was getting a bit strange. Right, okay, so try again. So this time, 2 squared is 4, and 2 times 2 is 4. And here, minus 2 squared is still 4, but minus 2 times 2 is minus 4. So we've got these 4 values. And if you notice, all of the y values are different, but their x values are in pairs. How can this be possible? How can you have the parabola and then have 2 points on the parabola with the same x-axis? Well, no one said it was a parabola like this. It's probable, and especially because the t-squared is on the x, that the parabola is actually facing the other way. So if this is our circle, we've got our parabola coming through like this. And so here are our values when x equals 1, and here where both x values are 4. So I think that's what's happening in this case. Great, so that's found all 4 intersection points there. Let's have a look at the second example. Find the values of t at the point of intersection of the line y equals x minus log 3 and the curve with parametric equations x equals log of t minus 1, y equals log of 2t minus 5 for t is greater than 5 over 2, and give the exact coordinates of this point. Right. Well, that's exciting, isn't it? All these logs everywhere, slightly worrying, but looking at it again, we've got an equation here in x and y. We know what x is, we know what y is. It says find the value or values of t. Well, we can do that if we just substitute in what x and y are and have an equation in t. So let's give it a go. Put in the y, and we're going to get the log of 2t minus 5 equals, put in the x, log of t minus 1 minus log of 3. They're all natural logs, so we can combine them. Subtracting like this, we can put this together as a fraction, so say it's log of that over 3. And then because we've got a log of a log, we can just get rid of it. And we can just say, okay, well, don't need that anymore, and we don't need the brackets. So actually it was nice and straightforward, and we're going to end up with 6t minus 15 equals t minus 1. Or 5t equals 14, is that right? Add the 15, but we've got minus 1, so t is going to equal 14 over 5. And we just get that one value of t. Okay, so let's get rid of all of this, and now we've got that value of t, then we can give the exact coordinates of this point. Well, that's easy, because we're just going to work out the x and y coordinate, and then we're all right. So x equals log of 14 fifths minus a whole one is 9 fifths. Yeah, so we're just taking away 5 fifths, that's a whole one. And the y coordinate is going to be log of 2 lots of this. So what's that going to be? 28 fifths minus 5 fifths, and 5 whole ones, and 5 whole ones is 25 fifths, so 28 fifths minus 25 fifths is going to be 3 fifths. I think I've done that right. I think so. Okay, so these are our values here. I presume that this is not going to give us nice numbers, but let's just see what happens, just in case, but I really doubt it. 9 over 5 is, yeah, something quite horrendous. So I think probably when it says give the exact coordinates of this point, it's log of 9 over 5 and log of 3 over 5. Those are the exact coordinates of that point of intersection. So hopefully you can see from these two examples that it should be, haha, famous last words, a relatively straightforward exercise if you want points of intersection, because you can use this t as a bridge. If you have an equation with just x and y's, and your parametrics are set up as x equals and y equals, you can just substitute it in and solve for t. That gives you the t value where they intersect, which you can then put into your parametrics to find the x coordinate and the y coordinate, and therefore the pair of coordinates where they intersect. And sometimes there's multiple answers if there's multiple t's, but the good thing about parametrics is that each t value has one coordinate that goes with it. So you shouldn't find a situation where you have one singular t value, but that generates multiple coordinates. I'm not aware of that being able to happen, because these parametrics have to be written as x is a function of t, and you can't have a one-to-many relationship in that function, so it shouldn't happen. If you have any questions on that, then feel free to put them into the comments, but otherwise, cheerio for now.